Hello everybody, this video is going to be all about rectangles and different ways to represent rectangles and how to draw them. It's a beginner level topic, but I know that when I started this sometimes it was a bit confusing, and I think it helps to actually see how it goes step by step. So we have a frame buffer here. If you haven't seen it before, there's another video I made about frame buffers, so you can check it out. So this is like our example frame buffer. And let's say we want to draw this rectangle here, and we want to know exactly which pixels in our frame buffer to fill to draw this rectangle. It's going to be these guys. Let's say usually we get frame buffer a rectangle in the form of like something that has a width and height, and it starts at a certain position on the screen. This frame buffer, this screen, starts at the top left. It's pretty common, but it could also start at the bottom left. And if the starting is the top left, then the coordinate is always relative to the origin. So in this case, it's going to be like top left. But if you're working with the frame buffer and the coordinate system starts at the bottom left, then the position is going to be starting from the bottom left corner of the rectangle, usually. So we have a position, it has an X and a Y. So the X starts at column number 2. In programming, it's usually 0 based. In this presentation, I'll just use 1 base for simplicity and clarity. So we have columns and rows. So the first pixel, where the position of the rectangle is starting, is at the second column and second row in this case. Another way to represent a rectangle is with 2 points. One is the minimum, which is usually defined as the closest point to the origin. So in our case, it's the same as what we had in the position before. And then a max position, which is the furthest away corner of the rectangle, furthest away from the origin. So in this case, it's going to be at column 5 and row 4 in the 2D grid of pixels. And then there is another way to represent a rectangle that you can typically encounter. It's just in terms of like the bounds. So the left bound is 2, the right bound is 5, and the top bound is 2, and the bottom bound is 4. These are all different ways to represent the exact same rectangle. And you may encounter any one of those if you're working with 2D computer graphics. And how to go between those is kind of a thing you do all the time. Okay, so say we're working with like the width and height. And the position representation is kind of like the most intuitive thing to pass around. It's just because the width and height are kind of constants if it has the same size and shape, and you can just change the position to position the rectangle on the screen. So say we have a draw pixel procedure we're gonna assume that it exists for this purpose of this presentation. It's gonna be assuming that there's like a constant color, a current color that is set somewhere else, and we're just passing in coordinates and setting the values of the pixel with the particular coordinate of rows and columns. And as we saw in the frame buffer video, we have our pixels as a one-dimensional array, and we use the number of columns in the X value, and we add to it some offset, which is the number of columns in the frame buffer times the row number, and we just set the color. So we are assuming that we have such a procedure for the remainder of this presentation. Okay, so a rectangle is just 4 lines, 2 horizontal lines and 2 vertical lines. So let's see what a procedure that draws a horizontal line would look like. So we need some point to some starting value for column and the end column, and we need in which row we're going to be drawing the horizontal line. And then we're just going to go column by column, from the start column to the end column, and we're going to draw a pixel at the current column with the constant row that we got in the procedure. So for drawing our the first horizontal line of our rectangle here, our starting column is going to be whatever the x position is, which is just 2. So let's mark that on the diagram and plug that into our procedure. Our end column is going to be whatever the position x is plus whatever is left to represent the rectangle, which is the width -1. It's -1 because we've already drawn the first pixel in the start. So it's going to be 2 plus 4 minus 1, which is 5. Let's mark that as the end column of our rectangle, the end column that we're drawing the horizontal line in. So, and plug that into our procedure. And then the row, so the first horizontal line that we're going to draw is going to be the top horizontal line of our rectangle. So the row is just going to be the y position, which is 2. So let's mark that here and plug that into our draw horizontal line procedure, and let's just start walking through this. So we're starting in column number 2. So that ends up calling draw pixel with coordinate of column 2 and row 2, which intersects on pixel number 7. So we fill that in, and that fills in pixel number 7 in our frame buffer. And we move on to column number 3, and so we're now drawing pixel at column 3, same row, so row 2. That intersects in pixel number 8, so we put a pixel there, put a color there in the frame buffer, and so on and so forth. So next one is column 4, row 2 again, intersects at pixel number 9, we put it, and the last one at column 5, row 2, that's pixel number 10, put it, and that's our first line. Now we have the second horizontal line to draw, which is the bottom one. So the start and end of the column is going to be the same, and it just needs a different row, and this time the row is going to be whatever the position y plus whatever is left for the height, which is height -1, because again we've already drawn pixels in the first row of the rectangle. So that's going to be 2 plus 3 minus 1, which is 4. Let's mark that, plug that into a procedure, and let's start walking through that. Again, it's going to be the same thing, just a different row. So we're marking wherever we're intersecting and putting pixels in each intersection at that row 4 all the way up to column number 5. Okay, so now we have the two horizontal line. Now let's talk about drawing vertical lines. So we again have a start and end. This time it's going to be rows, so start and end row, and then a constant column that we're going to use. So we're going to loop over the rows from the start row to the end row, and draw pixel again with the same way of calling, just with a column and row. This time the column is going to be the constant and the row is going to be the thing that's changing. So starting row is going to be whatever the position y is, which is 2 in this case. Let's mark that and plug it into a procedure. End row is going to be the position y plus whatever is left, which is the height -1 again. And so our end row is 2 plus 3 minus 1, which is 4. So let's mark that and plug it in. And our column, the first column that we for the first vertical line that we're going to be drawing for the rectangle is going to be the left one, which is just going to be the position x, going to be 2. Let's mark that, plug it in, and let's start running. So the first pixel that we're going to intersect we've already drawn, so you're going to just overdraw it. It doesn't matter, it doesn't cost that much. We could do like an optimization that skips it, but in this case I'm just doing it the simple way. And then 3 is that ends up intersecting in column 2 row 3, which is pixel number 12. So we put a pixel there, and that puts it in our frame buffer. And then we go to 4. Again, we already have a pixel there, it doesn't matter, you can draw it again. And that's our first vertical line. The second vertical line for the right, the column this time is going to be the position x plus whatever is left for the column, so it's going to be width -1, so that's 2 plus 4 minus 1, which is 5. Let's mark that and plug it into our procedure, and we're doing exactly the same. First pixel we already had, that was 10. Second pixel is going to be column 5 row 3, which intersects in pixel number 15. We put a pixel there, and then go to the next one. It's 20, we've already been there, we draw another pixel over it, and that's it. We have our rectangle. Okay, so this is a common thing to end up doing, and this is the common representation that we're gonna get, but it's actually simpler to draw the rectangle using a different form of input, which represents the min and max coordinates of the rectangle. So the min column is going to be whatever the position x, and the min row is going to be the position y, and then the max x is going to be the position x plus the width -1, as we saw, and the max y is going to be the position y plus the height -1, as we saw. So if we have a draw rect procedure that just gets 2 points, min and max, we need to draw 2 horizontal lines, so that and they'll draw the top and the bottom horizontal line, and then the left and the right vertical lines, the different column. And then if we start plugging it in, so the first column is going to be whatever the min x is. Second column is going to be whatever the max x is, which we already pre-computed before. And our first row is going to be the min y. The second horizontal line is going to have the same coordinates for the start and end for the columns, but the row is going to be the max y. Then the first vertical line on the left is going to start for, I think this is a mistake, should say min y. Yeah, sorry about that. So we're going to start at the min y and to the max y in terms of the columns, the row, sorry, and the column is going to be the min x, and the last line is going to be the right vertical line. We're going to start at the min y all the way to the max y, again the same, but this time it and the right column, which is max x. And that's it. If you like it, hit the like button. If you want to see more of these, you can subscribe to the channel. That's it. Thank you. Bye bye.